Hello, everyone. Not a lot of you, but it's quite expected. It's totally fine. But yeah, funny enough, actually, we have like two topics around the same thing, exactly the same thing. Protobuf for a mobile app, one here for the Flutter, and I think one, like two rooms on our left, which is for Android native. So I'm not sure if it's either good or probably bad and boring because people brought that up quite often. But yeah, thank you for singing with me. So my name is Angga, and I'm a software engineer at ING Netherlands, the bank. And I am a Google developer expert in Flutter from Indonesia. Oh, the flag comes up first. So yeah, I'm originally from Indonesia. Raise your hand if you knew Indonesia previously. If you knew Indonesia. Okay, you knew the country. Have anyone ever been there? Raise their hand. You ever been to Indonesia? Nice. So yeah, you should go there. It's quite far away from here. I think approximately like 55,000 something kilometers. So quite far. I think it took me like 18-hour flight from Indonesia to here. But really glad that I'm here now. So I'm now based in the Netherlands, working for ING, and this is my GitHub. So all the practices, use cases that I used is always posted to my GitHub. This is my Medium. I have not started, writing that much. I used to write in 2018, 2019. But there's something about Flutter there, especially in the early days, not now. This is my Twitter. Hit me up on Twitter if you are on Twitter. And if you have any questions, any discussions, everything, just email me. This is my email. So a short story, probably a little bit of explanation why like no one is sitting here right now, is I was supposed to do my talk on Wednesday, which is the 5th, and it was on the last one. So it was this one. It was written, no session this hour, that should be me. But life happens. Actually, I brought my daughter here and my wife as well when we had a little bit of accident. So my babies got spilled by like boiling hot water. Really unfortunate. So at like 1 p.m., 1:30 p.m. or something after lunch in here, on Wednesday, I need to go to the ER with the ambulance and everything. But yeah, I really didn't know when I go to the hospital. I think it was St. Johnson Krankenhaus or something. Because I get this impression that German people are like really cold and stuff, but actually no. They were really friendly, they were really nice. And yeah, I'm so glad that it was all behind my past. But one punchline is 3 hours later, do note that I was actually running through here, from here through, I think like the center of Berlin or something. I need to take the bus, taxi, basically everything. And then this actually happens, like 3 hours later, yeah? Kids, right? You really never knew what is there in their head. But yeah, all in all, right now she's fine, completely fine, healthy and all, just needs like couple of days for recovery. But yeah, it's all good now, all good. So no need to worry. So yeah, back to my topic, which is the common, we'll start with the common data format used in mobile. Usually this will be used by, for example, like inter-mobile communication. For example, you need to communicate from one component to another Flutter component, let's say, or probably from the Flutter component to the native component, or you need to communicate from the mobile component to the server component, let's say using REST API and stuff. Usually, off top of our head, like the solution is JSON. It's just like that. It just works, right? So JSON, if you didn't know, which I doubt, stands for JavaScript Object Notation, and then it's lightweight lightweight format for storing and transporting data, and yeah, blah blah blah. And the biggest power of it is it's self-describing. By just seeing at the screen, you already knew what the JSON looks like, pretty much what it will be used for, and then how can it be modified and everything. It's already self-describing and quite easy to understand, especially for non-programmers. Please do note that. But there is actually a catch with JSON communication, which is the algorithm. So for example, in Dart, when you do this, JSON string, let's imagine this is like the actual string. And then when we try to decode by calling like JSON decode and then passing the actual string, this is what actually happened under the hood. So this is quite a long, tedious process. For example, if we can, just run through what is actually happening when we are trying to parse JSON is, it is trying to find for this symbol. And then after that, is there any white space there? Or if something happened. And if there's like nothing at all that they are trying to find, it will throw out a format exception, which is an exception that, okay, the JSON cannot be parsed at all. And then it's actually done on runtime, which means our memory, our CPU is being eaten by this process. So this process is called marshal and unmarshalling. So marshalling means, we're parsing from JSON to the actual object from our programming language. In this case, it's Dart. And then unmarshalling is backward. So for example, if you want to convert this to a JSON, it's called unmarshalling. The problem raises is, what if we're transmitting a lot of data at a time? Let's not say like 1,000, but what if we're transporting like 10,000, 100,000, 1 million, let's say? What would happen with that process that is being done at runtime? And what about the time and performance cost? For example, one problem that we see is like the bandwidth needs. If you see, JSON is human readable, which is really nice, right? Because, for example, you can just pass the JSON to your QA, and then after that, they will explain it just like that, because it's quite human readable. It's really nice to understand. But because of its power, it actually creates some overhead to the format. For example, this is the pie. Actually should fit easily in 4 or 8 bytes, depending on what type of data you're storing it in. But with JSON, because you need it to store it in a string, it will consume 13 bytes in ASCII, which is probably like 3 or 4 times the actual representation should be, right? So it creates a lot of overhead. And then the third one is the data types. Data types of JSON is quite limited. So it does not support extensive data type. For example, enum. Enum is not supported in JSON. So if you want to do enum, you have to do it manually. Let's say you need to store it in a string, and then after that parse it in your Dart file, and then do the conversion transformation from JSON or string to enum, so on and so forth. So it's quite a long process. And then JSON only have one definition for each floating point numbers. So they call it numbers, or probably in Dart we call it double. And then integers, they only have one. So they don't have long, for example. Or other floating point numbers format, they don't have it. What if we need more? So we needed more precision in our use cases, rather than, okay, it's okay to round up, it's okay to convert from double to other floating point formats. It's totally fine. What if it's not? Then that is our problem. So I'm here trying to discuss more about the solution to this problem that I have faced in my previous experiences, and that is called protocol buffer. So protocol buffer looks pretty much like this. So it's a serialization mechanism developed by Google. So its basic idea, off top of my head, that I can think of is, for example, JSON is doing everything on the go, right? For example, I need to parse the string to my object, so I have to do it on runtime. But what if we already knew what our object looks like, and then we want to do that beforehand? So in compile time, for example, before we actually run any code, do anything, we already knew, okay, so this is the serialization, what the serialization looks like. So it doesn't have to actually guess, okay, after this, what character would come next? After this, what would happen? But it's already being decided in compile time, which is quite good. So it would work based on a schema called the protofile. You can imagine this as like your model. So you already define your model in something called schema, or in a .protofile, and it would define your model. So everything is already being done at compile time. And then after that, objects, instead of being sent as like a simple string in which people can just see and then guess what it looks like, but the runtime would also have to guess what it looked like. can actually be sent just in a simple byte. So you don't have any string and everything. Let's say the overhead that I talked about previously, it would not be there because it's already guessed. But the catch is it's actually mainly used in microservices. So not, at least from what I understood, not a lot of front-end guys, especially mobile developers, actually use Protobuf for their use cases. But I will explain in the next slides. Actually, we can try to utilize Protobuf for like more powerful use cases. If you want to know more about Protobuf, head up to protobuf.dev. So how does Protobuf works? It just in a 3 really simple steps. So first, you need to define your schema, which is the model. Okay, my model is just be an album which has an ID, a title. We'll talk about the actual definition after this. Artist and the price, let's say. That's our album. And then we have another model, which is called list of albums, which is pretty much defines itself. A list of albums. So we have like the repeated or list of albums in here. And then after that, this file will be distributed in our client app. So in this case, would be in the Flutter, Dart side, or probably if you want to use it in Android native, let's say, or iOS native, it's perfectly fine as well. And then after that, Protobuf had this like compiler, and then they will generate code from your schema to the programming language that you're using. And I will go on after this. They actually have like extensive support for most modern programming language named Java, Kotlin, Python, Swift. Yeah, basically any programming language that you knew and quite popular is already supported by Protobuf. And then after that, you can easily convert your bytes, because I previously talked that we can just transport bytes with Protobuf to the generated object. Something like this, if you can see. So just list of albums dot from buffer and then the bytes, and then just like that, the magic happens. And it's done in runtime. Sorry, in compile time, because everything is already decided for before you actually like build your app. You don't have to guess or anything. Okay, let's talk about the schema. So for the schema, this is like an example of the schema. We'll try to explain. First, usually what we'll have is like the version of the Protobuf, because they're keeping evolving. So for example, we used to have like Proto and then Proto 2. Right now we have Proto 3. Maybe in a couple of years they will update it again to be like a Proto 4 or something. This might be like the drawbacks, I think, because everything is already being done in compile time. So if they need to change something, they need to define it in like a different definition, let's say. And then the nice thing is you can actually not work only in one like really big proto file, but you can also like manage it to different files, so it can be organized quite nicely. And then you can define an enum, which is really nice. You cannot do this in JSON. And then this is quite a self-definitive, I think. Enum corpus, and then you just need to specify your enum. Let's say this is A, B, C, and then you need to define the ID of the enum. Basically, this is just like an incremental number. So 0, 1, 2, 3. And this is also nice because my backend engineer used this function to actually communicate the usage of these models. So in my previous company, all the management of the the proto file is actually managed by my backend engineer. So I have no idea about that. So for example, their model definition in backend is also written in the Protobuf. So in a way, it also acts as like a self-documenting facility, I think. So I don't have to do any swagger or anything because I already knew this is what they use in the backend. So it can be used as is. It's really nice. And inside the message or class, you can add variable just like you add the enum. Just add the like self-incrementing ID. So can be 0, 1, 2, 3, or 1, 2, 3, 4, 5. Yeah, something like that. The next one, the last one. You can actually use this like repeated or like a list. I've already shown you this before. And then you can also use map. in JSON. In JSON is practically a map, so it's fine. And then this is, I think, like the cherry on top in Protobuf. You can actually use this data type called one-off, in which you can have like multiple types. For example, in some time, it can be a string, but sometime it might be an integer, let's say, or a double, or like a map. It can be easily done in Protobuf. So it's quite extensive, the data type support. So what is the benefits of actually using Protobuf? Okay, it's good and all, but what are the actual benefits? So first is its compact storage needs, because we don't need any overhead. We don't have any spaces. We don't have any curly braces. We don't have any like double quote or anything. It's all in bytes. It's already, being decided at compile time. So like the machine you knew already what like the object looks like. So yeah, it doesn't need that overhead that JSON has. The second one is fast parsing. You'll see after this. I will show a little bit of experiment that I do. What is the comparison between JSON, XML, and Protobuf. And it's self-documenting, as I explained before. It's available in most programming language. So let's say you're not a Flutter developer, but let's say a backend developer, a React, let's say, or Android native, you can use it anywhere. It's pretty much quite flexible. You can really use it anywhere, as long as they have like the support for the Protobuf compiler. And it supports a lot of advanced data types that I didn't show here. For example, if you want to show like a date, so you don't have to actually parse it on your mobile client. Also latitude, longitude, which is for maps. Previously, let's say you have to like parse it by yourself in your programming language in Dart, for example. You don't have to do that. It's all being taken care of by the compiler. So it's really nice. So the language support for Protobuf is quite extensive. This is one of the most popular, I should say. So they have Android native support, which we'll get back to this later. And they also have iOS native support. And Swift is not listed here. It's not supported officially by Google, but Swift team actually created their own compiler, which makes it, it works then in Swift. So no problem at all. And we have Flutter support. It's really nice. So what is the performance comparison between JSON and Protobuf? So what I do is I created like a small server, sending the data from the server with 3 formats: JSON, XML, and Protobuf, and I compared them by numbers. What I do is I use Rust. That's the easiest one. And then I connected this sample app, a really simple one, that fires the API and shows or measures the time and speed needed between the calls and everything. And I ran the sample with 100,000, 10,000, 100,000, and 1 million data set, and I create like a simple graph to actually see what is the difference. Is it really that good, like people are marketing about? And here's the results. So first, for time comparison, you can see that actually, so this is the actual data and this is the graph. And do note that this calculation includes response headers as well. That the duration between JSON, XML, and Protobuf, probably XML is quite a huge difference, even when it reaches like 100,000, I think, in here. But with JSON and Protobuf, the difference is not actually that big. You can see, even when it reaches 1 million in here, there's only like little small difference. So if this doesn't really matter to you, probably it's not that worth it, I should say. Yeah. Protobuf had fairly faster performance to compare to JSON XML, but yeah, not that much. After this is the space. What about the amount of data, the sum of data that are actually being sent from the server to the client? So you can see XML is way above the numbers here. So that's why a lot of people are not using it anymore. Probably just a small amount of people. But with JSON, actually the difference is quite significant. If you can see, started from 100,000 in here, up into like 1 million or 500,000 in here. Yeah, the difference between, so this is JSON, this is Protobuf. So you can space a lot of, space or bandwidth, you can say. If you want to send the data from JSON to Protobuf. Yeah, it just makes sense, right? Because you don't have that overhead of having to actually write like double quote and then like parentheses and everything. It's already, yeah, it doesn't make any sense in Protobuf Word. So this is the result. So it's really nice, actually. Being able to, have this advantage. Not sure if you'll use it. I think it's case per case. For example, in some cases, okay, just 500 millisecond difference is nothing for me. It's not that big of a deal. It's fine. But for some apps, actually, where it's quite time sensitive, also bandwidth sensitive. Let's say you're building an app that is being used in a remote area, which even like 1 kilobyte really matters for your users, then this might make sense because you'll save quite a lot. And that might turn into money in the end. Because remote area, let's say you don't have like a good reception, and then, yeah, it will help your customer. So it's quite good. So what are the other use cases other than, surfing a protobuf from the server to clients? So this is the first one. This is the example. I can just, call a list of albums, dot from buffer, and then pass in the bytes. Yeah, just like magic, it's already done. It's so cheap, like it's almost nothing. So this is the first use case. Yeah, and we'll use the generated the protobuf Dart code. The next one is actually you can use this for meta-channel communication. So for example, you want to like communicate from your Flutter side to the native side. Let's say a huge amount of data, and then let's say in 100 millisecond, you want to get like 100,000 data. Let's say 100,000 integer for whatever reason it is, right? You can actually use Protobuf for this by so Protobuf, like I mentioned before, works great in native, right? Both Java and Kotlin. This is only for Android, but it's perfectly the same with iOS as well. So you can actually use that advantage to, for example, what I do in here is I send the data as a byte array to the Flutter side, and then after that, passes bytes, and then after that, I just, list of albums that from buffer, and then the data that is received from native, and then you can do this like vice versa. It would be the same. And yeah, this technique can be handy, I think, if you want to communicate extensively between the Flutter layer and the native layer. Let's say, or you can actually, in some cases, I think my friend from the Philippines actually used Protobuf to communicate between one Flutter engine to another Flutter engine, because time really matters between, Flutter engine communication. So yeah, it's really nice to be able to actually do this with Protobuf. And the number with 100,000 sample data that I tried is, so this is the meta channel, trying to communicate between native to Flutter with 100,000 of data. It takes like 37 milliseconds. While if I use Pigeon, so they have their own codec, it takes 195 milliseconds. So there's quite some difference. So this probably will not make sense if you only pass in like, I don't know, 10, 50, 100 data. But once you reach thousands or 100,000s, probably this kind of difference really makes sense to you. So yeah, really keep that in mind. Another use case in Protobuf is actually you can save local data to Protobuf. So previously, let's say I want to save like some set of data, and then let's say SQL is a bit too much from me, that I have to set up the database, the query, and everything. But probably JSON is a bit too heavy for my app. So that let's say I load the JSON file in the beginning of my app, it will take like the loading time a bit slower, but I can easily use Protobuf for this. So for example, this is like a usual object. I created like 100,000 of them. This is just a sample. And then after that, I assign them into bytes, and then I save them in a file. Yeah. And then I also try to compare them with 100,000 sample data. So this is local file with Protobuf. For 100,000 data, the duration to fetch, parse and everything is only 76 millisecond, which is quite, 76 millisecond for me is probably nothing, right? And then the response size, the size of the file, is roughly 4 megabytes. While with JSON, you actually need 195 milliseconds, which is more than double, I think, the actual duration. And then this is probably what really matters, because the response size, the file size, if we save the same data in JSON, is 5, almost 6 megabytes. So yeah, this is probably small difference. It doesn't really matter when you only save, let's say, 100, 500 data. But once you reach that point, or probably when time is, let's say, like 10 milliseconds is really important for you. One good example is, for example, if you are communicating to that Flutter engine to another Flutter engine, so 10 milliseconds is really important. If you can save like 5 milliseconds, 8 milliseconds, that would be really great. So yeah, Protobuf might be a good use case for this. And then yeah, this is just 3 examples that I can show. Of course, there can be hundreds of them. For example, if you want to do like communication between Dart and another Dart component, you can definitely use Protobuf. It might be a good use depending on the use case. And then if you want to communicate between native and another native layer, that would be great as well. So yeah, keep playing with your imagination. It's quite good, I think. So yeah, the question raises is, when should I use Protobuf over JSON? So, okay, so it's good and all, but do I really need it? Or probably I don't, right? So first is you need to ask yourself, do you have like a lot of data transmission that requires heavy performance? One example that I can imagine is like a game. Because in a game, you really need to communicate a lot of data, let's say with the servers, with the native side, let's say. You have to communicate the player score, let's say, and then the player friends. Basically, you'll easily end up with, I don't know, 1,000, 10,000, 100,000 data for that particular user, because you have to save like a lot of data. So this might be a good use case. One of my friends is also using it. And then if faster and smaller communication really matters for your app, so you might want to think if this is a good choice for me. And if type safety is really important to you, so for example, in JSON, a lot of things are getting casted, right? It's getting truncated and everything. If you don't want that, so this might be a good solution for you as well. When should I not use Protobuf? In other hand, if JSON already suits your app, then stop here. You're probably already good. You probably won't have to, dig deep into, okay, how does this work? Do I have to convert all of my objects and everything to Protobuf? Do I need to, let's say, force my backend engineer to actually use Protobuf? All that stuff, probably you don't need that hassle. Well, life is already hard anyways, right? Yeah, the second one is, yeah, you don't want all the hassle, especially this is for server to mobile communication. The third one is, if you need a lot of debugging, let's say you want your QA to be able to see all the JSON requests and everything, probably Protobuf is not a good idea. Why? Because you have to explain to your QA, this is Protobuf. You actually need to be able to compile and everything. And then probably it just makes life harder for them. So don't go for that direction. And yeah, for sure, when your client programming language does not support Protobuf, but to be honest, I did not see any programming language, like modern programming language and popular ones, that are not being supported by Protobuf. So probably this is out of hand. Yeah. So where to go next after this talk is, you can clone this sample project. After this, I will show a QR, the sample project that I showed previously, and try it in your own machine. See how it works. See how you can, try to replicate it in your own pet project, and explore more about Protobuf. There was actually a good discussion just before this talk. There is actually other alternatives. If Protobuf is even not that fast for you, for example, you want to cut from 76 milliseconds for 100,000 data to, I don't know, 20 seconds or something, there's also 2 more solutions that I have not talked about in this talk, which is flat buffers, created by Google as well, probably not as mature as Protobuf. Also, another one is called Cap and Proto. I think they have one more, which is the BSON, which stands for binary JSON. So you can imagine JSON, but in binary. But I have not explored that. That should also be quite fun if you want to just play with it and then try. And then see if Protobuf will be suitable for your past or upcoming projects. And I knew there was a talk about gRPC as well, probably yesterday or the other day. But yeah, if you combine both Protobuf and gRPC for your server to mobile communication, it might be really powerful, even more powerful than this, because this is mostly like local use cases. So yeah, this is the resources. Thank you so much. This is the slide and the code sample. If you have any questions, raise your hand. Thank you.